This is the first question from the 6th-year midterm test. It's a linear sequences question. We have a formula given to us. Tn is 38 minus 4n, where n is 1 or 2 or 3 or 4, and it asks us to give us the first three terms of the sequence that's defined by this formula. Well, all it's asking us to do is substitute 1 into the formula, then 2 into the formula, and then 3 into the formula. So we just substitute the various different values in. So for T1, we put 1 into there. For T2, we'll put 2 into the, instead of, and this each time we're putting instead of the n value. And T3, for the third term, we're going to put 3 into there. And what we get as an answer is 34, 30, and 26. Now they can be done on a calculator, but they're the three terms. 34 is the first term, then 30, and then 26. We then ask for the first negative term of the sequence. So basically the idea is you're supposed to realise that as the numbers go down from 30, 34, 26, going down by 4 each time. So if we were to continue with this, we go 22 and then 18 and then 14, and we get to a point eventually where we get to 2, and then we go to minus 2 and then minus 6 and so on. Each time, the key idea here is each time we're going down 4 each time. Take away 4, take away 4, take away 4. Take several 4s away, you get down 2, take away 4 to minus 2, take away 4 to minus 6. So in this instance, our first negative term is minus 2. That's not the only way to do it. We could have instead just gone through just a process of doing these formulas, just substituting different numbers in for my n value. So just try out the 8th one to put 8 into the formula, then try out 9th one to put 9 into it, and then put 10th one into it, and realise, oh, hang on, just random numbers until you into the formula to find the one that fit your requirements. That's another way, just a sort of a brute force trial and error process. And the third, and I suppose the most mathematically correct way of doing it, would be to take the formula, the 38 minus 4n, and the whole idea, this sequence is defined by this formula, and we want to know when this formula is going to equal to something less than 0. So we're solving this inequality, which is something you've done from junior certificate. So if I take away 4n from both, or add 4n to both sides, I get 38 is less than 4n, divide by 4, and I'm going to end up with 9.5. Okay, so in this instance, we read this line as 9.5 is less than n, i.e., going in that direction, n is greater than 9.5. So when is n going to be greater than 9.5? It's going to be greater than 9.5 when it's 10. So when we take that value and do the 10th term, we find that 38 minus 4 lots of 10 gives us our minus 2. Moving on to part C. What we're asked here is to come up with the sum of the first 15 terms of the sequence. So again, I suppose a brute force, it's just a sort of straightforward, just working through it. It would be to sit there and literally just add up for 34 and 30 and 26 and 22, and just add all those numbers up that we mentioned in part B. Okay, and it carries on, it goes down to 2, and then it becomes minus 2, and then it's minus 6, and carry on and carry on. Okay, so in this instance we've got there was the 10th term, 11th term, and just carry on with a few more after that until we get to the 15th term. So we end up minus 6, and then minus 10, and then minus 14, and then minus 18, and finally my 15th term is minus 22, because that was the 10th, 11th, 12th, 13th, 14th, 15th. I mean, literally you just count them all. Count them all up, add them all up, and you get the answer of 90. That's not the only way to do it. Okay, now if you look at this string of numbers I've got here, you'll notice that some of the numbers are sort of opposites of each other. So we have 2 and minus 2, and there's actually a 6 and a minus 6, and a 10 and minus 10, minus 14 and minus 14, minus 18 and minus 18, and 22 and minus 22. And you'll realise that all these numbers in this section here of the sum actually cancel each other out, because 22 and minus 22 cancel each other out. The 18 and minus 18 cancel out. The 14 and minus 14, all the way down to 2 and minus 2. They all cancel each other out. So actually, if you just look at this, what we end up with is 34 plus 30 plus 26 plus effectively a sum that is 0. And if you add up 36 and 30 and 26, sorry, 34 and 30 and 26, you get the answer of 90. So that's another way of approaching it. The last approach, which again is the most mathematically appropriate, is to use the form that's given to you in the formula book. And you have Sn equals n over 2, 2 lots of A plus n minus 1 d. So using that formula, so n is the number of terms, A is the first term, which we worked out as being 34, and d is the common difference, which we've realised hopefully is minus 4 each time. So when we work out S15, it's basically a case of working out the following sum. 15 divided by 2, 2 lots of 34, plus 15 minus 1 lots of minus 4. And when you work that through, we get 7.5 multiplied by the sum of 68 minus 56. And 7.5 times by 12 gives me 90. Lastly, to part D, well again there's a variety of different ways in which you can approach this question. So again we're looking at a sum of the terms. So again we're talking about the 34 plus 30 plus 26 plus 22, etc, 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 all the way down to 6 and 2 and minus 2 and minus 6 and carry on and carry on. And the idea here is, at what point in time are they going to add up to 0? Well, using the idea that we discussed in part C, this idea that actually we realise that we've got a sort of symmetry here, we've got positive numbers and then we've got negative numbers, and those negative numbers are the same as the positive versions, and so effectively we have a situation where they cancel out. So we're going to, the 2's cancel out, the 6's cancel out, the 10s and the 14s and the 18s and the minus 22s, and the idea here is that we carry on, and after we've got minus 22, we've also got minus 26, and we've also got minus 30, and we've got minus 34. So the whole idea is that each of those terms are cancelling each other out. So it's purely a matter of just realising how many terms I've got listed there. And you could literally sit there and count them up. If you've written them all out, okay, which is not a bad thing, you can actually count them up. Well, minus 2 was the 10th term. Actually, the one before it was the 9th, so all of those make 9 terms. And so we wanted another 9 terms that are exactly the same but negative. So 2 9s is 18. So we have a situation where our answer is n equals 18. Now that's not the only way of doing it. Again, that's sort of just going back to absolute basics. But you could use the formula that we discussed a moment ago in this section here. We have this formula here, and it's a matter of just equaling this to 0. So what we're saying is, what values of n will give us a situation where n over 2 multiplied by 2 lots of 34 plus n minus 1 lots of minus 4. At what point in time does that formula equal to 0? And tidying that up, we're going to get n over 2, 68 minus n plus 4, which works out as n over 2, 72 minus 4n. And the key thing here is, now you could open up all the brackets, get yourself some complicated quadratic and try and solve the quadratic, but most of the work is actually done for you already, because you've got basically two things multiplied together. You've got your n over 2, and separately you've got 72 minus 4n. And those two things separately are multiplying together to make 0. So one of them must be 0. So we have a situation where either n over 2 equals 0, well that's only going to happen if n is 0, or we have 72 minus 4n is equal to 0, in which case, when we work it through, 72 divided by 4 gives us 18, which is the same answer as we had the other way, as you can see up here.